Good day, doctor. I am Yong. My metric number is 2010909973. I'm your Group 1 student. This is my open-ended Lab 3 Laboratory Module 5 DC machine. The introduction of a series DC motor in which the field winding consists of a relative few turns of thick wire connected in series with the armature winding. The second one is the DC shunt motor is one of that has the series field winding coupled in series with the parallel combination of the shunt field winding and the armature winding. The performance characteristic DC motor are the first one is speed armature current characteristic, torque armature current characteristic, and the last one is a speed torque characteristic. The next one, in this report, we able to understand the limitation parameter and demonstrate the torque speed characteristic of DC series, able to understand the control and speed limitation of DC series and shunt good motor, able to understand the purpose and insulate the DC separator connected motor arrangement experiment step. This is circuit. This is circuit diagram and the symmetric. Okay, the figure 3 show the equivalent circuit of a series DC motor. The next one is the equivalent circuit of DC shunt motor. This one is the methodology for part A, connection and motor direction control. Part B, torque speed characteristic. Part C, speed control. Part D, magnetization curve plotting for DC shunt motor. This one is my result and analysis torque speed characteristic for DC series motor. For the torque versus armature current characteristic, the higher the current, the higher the torque delivered by the motor. The next one is the speed versus armature current characteristic. From the graph, from the data we obtained, is clearly stated that the speed is inversely proportional armature current as the flux is directional proportional to the armature current. For the speed torque characteristic, when the speed of the DC motor is decreased, the torque will increase. Okay, the next one, the motor current must not exceed 130% of the rate current as long as starting scores of the inrush current. The motor will unlimited overheat and eventually feel permanent after running for a long time. For the rate current of this motor is 1.76 current. This one is the speed control for DC series motor. Okay, as you can see that the increase in armature current, the decrease the field resistance. When the field current is decreased, the field flux is reduced and the counter EMF is decreased. The last one is the current versus resistance of the DC shunt motor. Armature current is inversely proportional to the resistance and direct proportional to the applied voltage. D is the magnetization curve for DC shunt motor. So as we know that a DC generator magnetization curve does not initially begin at 0. So it will begin with the produced voltage value caused by the residual magnetizer. The next one, this one is the discussion for part A, connection and motor direction control. For the normal connection is clockwise, for the reverse connection is anti-clockwise. So we have to consider the relation between both of connection and the direction of rotations when designing a DC motor system. Part B is the torque speed characteristic. Okay, as we know that the torque is produced is directional proportional to the current flowing through the armature winding. The higher the current, the higher the torque delivery by the motor. The next one, the speed control. Speed control, as we know that the speed control of DC motor refers to the deliberate modifications of driving speed. A DC motor speed can be adjusted manually by the user or automatic via a control magnetizer. So the D is the magnetizing curve for DC shunt motor, and the DC shunt generator is a self-excited generator. The field current creates the magnetic flux in which the armature rotates. So as the The EMF may be considered equals to the voltage between terminal when the generator runs without load. E equals to Vt plus IARA. This one is the formula. Okay, the next one is the table comparison for DC shunt motor and DC series motor through the theoretical and physical assessment. This one is the efficiency rate of the DC series motor. This one is the DC shunt motor for the efficiency rate. This one is the characteristic of separated exciting DC motor. In the separated excited DC motor, field and armature current are excited to form two various DC supply. In this motor, the Kirchhoff flow equations E equals to VA plus IARA. The conclusion: all the experiment has been performed to characterize DC machine based on the simulation or physical approach. All the data has been analyzed and obtained results of the experiment and related them with theoretical and fact that we learned in book. For the recommendation for improve the motor efficiency, the there are few important ways to take into consideration. The first one is eliminate voltage unbalance, replace V belt with clutch or synchronized belt drive, avoid using tripping, and last one is maintain motor shaft agreement. This one is my open and the LED 3 DC machine. Thank you.